Today we're going to take a look at how to solve and simplify cube roots. The first thing we're going to do is list all of our perfect cubes. So we start by saying 1 times 1 times 1. The value of that is 1. So 1 is our first perfect cube. Then we have 2 times 2 times 2, which is 8. 3 times 3 times 3 again is 27. 4 times 4 times 4 is 64. And we can continue on doing that multiplication to find the rest of the perfect cubes up through 12. And here we have our list of the first 12 perfect cubes. When we look at perfect cube roots, we have a radical with that index of 3. That means we're looking for a perfect cube, and we're wondering what number times itself again will equal 8. And if we look at our perfect cubes, 8 is the second perfect cube we came up with, so its cube root is 2. When we take a look at the next one, we bring that 5 along for the ride. And we look at 343. Well, let's see. That was 1, 2, 3, 4, 5, 6. That was my 7th perfect cube. So the cube root of that is 7. Anything outside the radical will get multiplied by other things that are outside the radical. And we get a value of 35 for this one. The cube root of 27, that's my third one, so that must be 3. And the cube root of 1,000 is 10. Those were all perfect cubes. If I have non-perfect cubes, then we're going to take a look at our next part, non-perfect cube roots. We're going to go ahead and this should say perfect cube roots. We're going to factor the radicand using a factor tree. And this time we're circling groups of 3 identical factors. We'll remove the triplet and represent it once outside the radical. And any other factors that do not make a triplet will stay put. After that, we simplify factors outside the radical together and those inside the radical together. So if I look at the cube root of 40, I'm going to factor it with prime numbers. 2 and 20, 2 and 10, 2 and 5. We're looking for a triplet, and I have a triplet. I have triplet 2s. So because I have a triplet of 2s, we write 1, 2 outside the radical to represent this triplet. And my single value, or anything that's not a triplet, will stay in the radical. We want to make sure our radical has that cute little 3 as the index, and the 5 is going to stay in the radical. So this is 2 cube root 5. Moving on, we have the cube root of 192. Well, I know that 192 is divisible by 2 because it's an even number, so I'll get 2 and 96. I'm now looking at maybe 3s. 3 goes into this 32 times. We've got 2 and 16, 2 and 8, 2 and 4, 2 and 2. So quite a long list of factors. We're looking for triplets. Here I have a triplet of 2s, and then we also have this triplet of 2s. So that means I'll represent this one outside the radical 1 time. I'll represent this one outside the radical 1 time. And my 3 is all by itself. That's going to stay in the radical. Outside the radical, we simplify by multiplying. This should be 4 cube root of 3. Back to number 7. Again, I have an even number, so I'm going to do 432 divided by 2 and see what we get. We get 2 and 216. 216. Let me look back up at my list of factors, or perfect cubes. Here's one. The cube root of 216 is, let's see, 1, 2, 3, 4, 5, 6. The cube root of 216 is 6. So I already know this is a perfect cube that equals 6. And I'm going to have a 2 left over. But let's see what it comes out to. If we keep going, we've got 2 and 108, 2 and 54, 2 and 27, 3 and 9, 3 and 3. So we have a set of triplets here, and we have a set of triplets there. So this 2 is going to go outside the radical. This set of 3s will come outside the radical. And this single 2 is going to stay in the radical. And 2 times 3 is 6. And we have the cube root of 2. So once we found a perfect cube like this, 216, we could stop there. We take the cube root of 216 to be 6. That's outside the radical. And what was it multiplied by? It was multiplied by a 2. That's why that's in the radical. We'll take a look at our next one, 189. Well, let's see. Is 189 one of our perfect cubes? Nope, doesn't look like it. All right, so now we have to simplify it. Again, we have a 2 on the outside, so we're going to carry that 2 over to be multiplied by anything else that comes out of the radical. I see that it is not an even number, so maybe it's divisible by 3. We do 3 and 63. Let's see, 3 goes into this one. 3 goes into this 21 times. 3 and 7. We do have a set of triplet 3s. They're going to come outside the radical, and this little 7 is going to stay in the radical. We end up with an answer of 6 cube root of 7. Now I'm going to erase some of my work here so we can see what's going on with this next problem. We have negative 3 cube root of 96. So I know this negative 3 is going to come out and be just hanging out in front until we factor 96. I know that 3 goes into 96. It goes in 32 times. We're going to break up 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. We'll look for triplets. I have triplet 2s right here. And I don't see any other triplets, but I'm going to box all these single numbers. Remember, we're not looking for pairs or 2 of a kind. We're looking for triplets. So I can represent this triplet of 2s outside the radical. And then any single numbers are going to stay in the radical as a string of multiplication as well. So I have 3 times 2 times 2. And now we can simplify. Negative 3 times 2 on the outside is negative 6. 3 times 2 is 6, times 2 again is 12. And we have simplified our radical. We'll take a look at our next one as well. We again have a 4. We're going to bring that over, keep it on the outside, and factor 250. Ooh, 125 is one of our perfect cubes, but let's keep working. And we'll keep factoring this. We have a set of triplets. They are going outside the radical. And my single number will stay in the the radical. We will multiply outside the radical together and simplify anything else. We don't have anything else to do. The next portion of our notes talks about the cube root of a negative number and how it will always be negative. Just like the cube root of a positive number will always be positive. You could take a look at this, the cube root of -1. Well, can I think of a number times itself again that will equal -1? And we can. We have -1 times a -1. That'll make a positive. And then a positive times a negative will make a -1. As we continue simplifying our cube roots, if there's a negative in the radicand, we'll pull that negative sign out of the radical because this is really -1 times 54. And -1 is one of our perfect cubes. Its value is -1. So knowing that, anytime I see that negative sign, I'm going to pull that out in front and then simplify 54 as I normally would. 2 and 27, 3 and 9, 3 and 3. And I can look for my perfect cubes. Here they are. The 3 will also be outside the radical, and this single 2 will stay in the cube root. So our final answer for this one is -3 cube root of 2. Moving on to our next one, we'll pull this -2 and bring it along and out in front. And we'll also pull the negative sign out in front. So we have a 2 out in front and we have a negative sign out in front. Then we'll go ahead and simplify 128 as we did before. We could do 2 and 64, 2 with 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Looking for those cubes, looking for 3 of a kind. We have 3 of a kind there, and we have 3 of a kind here, and a single 2 that's going to stay in the radical. So this group of triplets is going to be represented outside the radical. This group of triplets also outside the radical, and that single 2 will stay in the radical. As we multiply, -2 times 2 times 2 is -8 cube root of 2. Next cube root, we're going to pull this -3 out in front, and we're going to pull this negative sign out in front. So really there's double negative signs out in front. This is really a -1 times -3, and we'll simplify 72. 2 and 36, 2 and 18, 2 and 9, 3 with 3. We have a triplet of 2s. That's also going to go outside the radical. And then we have single 3s. They don't make a triplet, so they're going to stay in the cube root. And we'll go ahead and multiply or simplify. So remember, we have that negative sign we pulled out in front and the -3. So -1 times -3 is a +3. 3 times 2 gives us 6. Cube root, 3 times 3 is 9.